Maths, bro. Fastest grind ever.
Alright. That'll work. That'll work.
I'm still mega tired though. I get so tired. I've got no food.
Marco's got a sense of humor today.
Yeah, exactly.
All right. So we've got a couple of transformations with this Batman W. It's really a parabola with a couple limits which are taking the absolute value of. And I don't know the equation for it, right? And I don't care. I've got the graph, and all I'm trying to do is do some transformations. If we were to put in a number like 3, first we'd add, and then we'd run the function, whatever it is, and then we'd multiply by -2, and then we'd subtract 4. So we're going to run our order of operations in the transformation the same way. So first, I'm going to make the +2 to the x. What does that do to the Batman symbol?
Shift it left.
Yeah, shift it opposite of what you think. So all those points go a 1, a 2 that way. Yeah, 1, 2 that way, so it ends up like that, more or less. And then we do that to it. What is that thing? The negative flips it over, I agree. It changes all the y values signs. So this one has 0, so it doesn't go anywhere. But this one goes from +4 to -4. Yes, recognize my W, please. Thank you. That's exactly what I wanted. So it does that. You get the drill. You get the picture. Drive it like this, order flip. Does that, and then like that, more or less. But there's not just the negative, it's also this. So what happens to it because of the 2? Yeah, it multiplies the y's by 2. And so 0 don't care, but this 4 gets doubled, so it turns into this. And Lord knows where those go. So it just kind of looks something like that. Stretches it out. Whoa, laggy. Cool? And last but not least, that takes all of the y values and does what to them?
Just goes downward.
Yeah, so pulls all the y's down by 4. So it should look like 1, shug, 1, 2, 3, 4. Voila. More or less. Cool? Cool. What's nice is I don't even need to know the equation for the bat symbol. You just mess with what we've got. All right. Ka-bing! Do you want to see anything from your home learning before we go? Feeling okay? I feel like most of my solutions are up to date. All good, you guys? With the home learning?
Yeah. I don't know what to take.
All right, then let's move on. So, you know how to do all of these things with algebra, expanding, and factoring. When you expand something, you turn it from a multiplication into just a big addition. So if you distributed, you'd end up with that. Going this way is called an expansion. And going this way, from an addition to problem, primarily an addition to a multiplication, this thing times this thing, this is factoring. They're just going opposite directions. And you can do that with something simple, or something like a binomial, right? No surprise, the A and C get together. This is the FOIL method. And we're going to couple this with our exponents in a second. The big ones that we're going to work with that come up over and over again are just basic distribution. Hey, look, they both have an A term, pull it outside. The other one that you'll see a lot is this one, where you get 2 of the same thing, and they turn into just a squared and b squared because that middle term, there's our a squared, here's our negative b squared, and the middle term is the same but opposite signs, gets canceled out. So that's the other one that we're going to be working the most with. The other ones you can just kind of figure out as you go. If you have something like a plus b squared, resist temptation to drop the square in. It doesn't work. Like 2 plus 3 squared should be 5 squared, should be 25. If you drop the 2 in and you get 4 and 9, not 25. So to make this happen, you need to go 2 plus 3 times itself, distribute 4, distribute 9, 6 and 6, and that's 25, right? Now, too much work if you have all the numbers, but if you don't have the numbers, you take something like this and you multiply it, you break it apart and call it a plus b times itself, and then you can distribute just like you would here. Neat, same with the negative, but it's just negative. Cool, so I don't think this is worth memorizing that this is this. It just kind of is a little more intuitive, but just the fact that if you have something squared, you just write it out in 2 and then FOIL it. We're going to play that game with some exponents. I'm going to do one. I'll have you do the other one. We're going to do that 3 times. We'll be done. Oh, I guess I'm just doing this one for you, or with you. That's awful. It is awful. But if you can do that, it makes like all the rest easy. So I want to expand, which means I want to distribute this into those pieces. All right, so we'll just run through this together. I think you can probably already do this on your own. But this is a dance of like, how much do you write down versus how much do you try to do in your head for speed? And that's a personal thing. That's your mathematical art form. Because I can definitely do this completely in my head, but I'm slow. Or if I'm not slow, I'm very prone to error. So I'm going to try to write it out. There's that part. Class. So just distributed it in. Sometimes it helps me if it's really chaotic to make a little parentheses. User's choice, up to you, helps me out because I can't remember, keep track of anything. And then when they're the same base, we're going to add those exponents. So maybe you want to do this intermediate step where you're saying -1/2 plus 3/2 all on 1. If that helps you, go for it. If it, like, when it matters and you're working the test, I definitely do that to, like, slow down. But since we're just cruising through, I'm going to add those. You get 2/2, you get 1, so that's just x to the first, which is nice. I might leave those brackets. That's 0. I like breaking up the 2 because it helps me visualize what's happening. It helps me separate the 2 from all of it. So I can see, it's a little easier to see now that you can pull out the 2 and just pop it right there. And so this becomes 2 times x to the -1/2 plus 1/2. That's 0. X to the 0 is 1. So this just becomes 2 times 1, just 2. This minus was from there. And then we're going to do the same thing. I'm going to pop the 3 out front. The halves are additive. And, oh, that one's negative. And that one's negative. Both negative. So we get -1 instead of -1. Cool. If you're there, I'm really happy. But I think you could clean it up and just call it x plus 2 minus 3 over x to the 1. Or just x. I think that's the cleanest form of it. Yeah, that's going to be the dance. And maybe you do it with, this is a monomial and a trinomial. Maybe it's a binomial and another binomial, and you like do the FOIL method, right? But it's all the same stuff. Just be careful with how you're adding and multiplying and all that good stuff. This is where it gets tricky. It's not really tricky. It's just a little fussy trick. So I'll do one and show you, and you'll do the other one. But we're going to try to do it backwards. We're going to simplify. We're going to try to factor. Turn it from like an addition problem to more of multiplication. You'd want to do that if you can like cancel things out. Sometimes it makes it simpler. That looks gross. But with your nerd goggles on, maybe you could see this part as 2 to the n times 2 cubed. All right, like if you had x squared times x cubed, this is x times x, and this is x times x times x, and there's 5 of them, so you'd add them. So this is x to the 2 plus 3. Well, we're just rolling backwards on that. And instead of calling it n plus 3, we're calling it 2 to the n and 2 to the third. Right? What's kind of nice about that is that if you thought about this already as a parenthesis, there's a 2 to the n here and a 2 to the n here, and we can factor those 2 to the n's out and put it out front. Tricky! 2 cubed is 2 times 2 times 2, so 8. We got to leave a placeholder there, right? If you factor this out and you don't leave a 1, it's no longer a binomial, and this one stops existing. So we got to leave a 1 there. If you redistributed this, you'd get this back, and you'd get this back. We're happy about that, right? So this is nice. What's even nicer is those two are whole numbers, or regular numbers that we can add together. They're 9, so this becomes 9 times 2 to the n.
I don't understand why you can factor it out. Like, you're not multiplying the 2n by the 2n.
Tell me that again.
Why can you factor it out?
Just like if you had 2x plus 2, you could say I have a 2 in this and in this. And just to make it a little simpler or look a little different, we could pull a 2 out of both of those, put it out in front. This would be left with an x and a 1. And if you redistributed this, and I'm just checking to make sure it goes back, this is this, and this is this.
But you have 3 terms.
But I have 3 terms?
You have 2 to the n, 2 to the third.
Well, this is just these two. And this one is this guy. Is that okay? This one is separated with a multiplication. These two are being multiplied together, and this plus
so you
breaks
treat
it
it as
up.
one thing.
Yeah.
Okay.
Yeah.
How did you go from the 2n times 2
From here to here?
3? Yeah, to that.
Cool. We said that this is 2 to the n times 8, essentially. And so this is 2 to the n times 8. You could think of this one as 2 to the n times 1. We said these two are common,
Yeah.
so let's pull them outside.
Mm-hmm.
What you're left with is the 8 and the 1.
Yeah.
If you redistributed this in, you get this, and this would give you that.
Mm-hmm.
Cool? And so this is nice. But don't make the mistake of calling this 18 to the n. Right? Just leave it and walk away quietly. Because this is 9 times a bunch of 2's. How many? I don't know, n of them. But if you're like, I like numbers, let's multiply stuff. And you multiply 18 and call this 18 to the n, that means this is 18 times 18 times 18 times a whole bunch of those. And that's not the same. Like if this was a 2 squared, right, it would be that, which is 18 times 2 should be 36. And if you multiply these two and kept the squared there, it'd be 18 squared, which is way bigger than that. All right, so just be careful with what you're doing. Since that has an exponent on it, n, it locks that power. Cool, and this just says I have 9 sets of these, so you can leave it like that. Neat, that's mine. You try this one. See if you can factor that. Think about looking at this one through a little bit of a different lens. use your intuition about what tricks might be up. All good, you guys? What kind of evil scheme do you sense in there? What do you see in there?
Yeah, a to the 2x.
Yeah. Yeah, I agree. Like, I think this is going to become quadratic. I think some mean-spirited person has buried a quadratic in this. And if we examine this,
Yeah, I think it's true.
we could call this a to the 2x. Well, 4 is a to the 2 times 2x. Yeah. That's okay, I haven't like broken any laws. And you don't always have to write this all out like I'm going to write it out, but I just want to show you that I'm not making stuff up. 2 times 2x is 4x. And instead of writing it as 2 times 2x, I'm going to write it as 2x times 2 for a specific reason. That's still 4x. Since we have a multiplication, that's really like a power on a power. It's sort of like saying x cubed squared. I have 2 sets of 3x's, so I get 6x's. So you multiply those. I'm going to think about 4x like this. And so I can think about, I'm targeting this thing. I'm looking to try to make those. Because if we do that, I've got an a to the 2x there, and I've got a 12. If you thought about a to the 2x, not as a to the 2x, but let's ignore our problems like normal and call it m for a second. Something different, right? This is m squared. Hey, look, that and that are both the same, so that's another m. What does that look like? Quadratic. Can you factor that? Yeah. And so we can take that and factor it and call it. You can skip the step with the m. I like it because it helps me compartmentalize. But that should make an m and an m. And a, 3 and a 4? Or did I botch the signs? The signs should be different. Yeah, that should be a negative 12, right? If this is going to work. Yeah. So then we can make this 1 positive and 1 negative, positive 4, negative 3. Sorry about the sign swap. If the signs were plus, you'd have to like throw in a quadratic formula and just get ugly. It would still work though. And then so we can call m as negative 4, or we could call m as positive 3. But it wasn't m at all, right? And usually when you look at my work solutions, here I will say temporarily let a to the 2x equal m. Especially if it's like an uglier factory that I'm like have to think about. And that reminds me later when I'm kind of stuck, like, what was I doing? Why have I got m's? Oh, right, m, and then I re-swap that out, resubstitute. This wasn't m at all, it was a to the 2x equals negative 4, and a to the 2x equals 3. Oh, sorry. There's no equal sign. We're just going to re-swap it in. We just wanted this to factor it. They didn't give us an equal sign, so we're just going to switch this out for a to the 2x. And a to the 2x. Cool. If there was an equal sign and they gave us a number that you could equate it to, you'd go for it then, or set it equal to 0 or whatever if you wanted to find real solutions. Can you do anything from there? I don't think so. Sometimes this can be broken up further, like if this is a difference of perfects of 2 squares, and that's a minus, you could treat this as a to the x. This is just an example. A to the x squared minus 2 squared, and that could break up into the a to the x plus 2 and a to the x minus 2. If this was a minus, it's not in this case, but I just wanted to show you that just all of the tricks, because these two would get together and give you this, these two would get together and give you this, and these are opposites, and so they cancel out. You wouldn't get anything in the middle. Yeah? It's all of the things that you know how to do blended together, which makes it annoying. And for our last trick, I'll do one, you do one. You can also be the ace of the base, change the base, and kind of look at things with a different lens, if you will. So that thing doesn't look like it can be factored because it has different bases. However, if you think of that 4 as not a 4, but maybe as 2 squared to the x, and 9 as 3 squared. Kind of like that, but I really wish this was the squared outside. Right? And so I know that you could, if you have like x squared cubed, you should say x. That means there's 6 x's in total, right? So you could say x to the 2 times 3. That's the same. I have 3 sets of 2, so I multiply those together. There's nothing to stop you from saying that, and that would mean that that's true. And that makes sense. Like 3 sets of 2 x's is 6 x's, and 2 sets of 3 x's is 6 x's, right? So mix and match as it's beneficial for you. So instead of calling it like this, I'm going to try to look at it like this. 2 instead of 2x, I'm going to try to call it x times 2, and therefore it's really x 2 to the x squared minus 3 squared. Now this is the difference of 2 squares. Tricky. Right? And from that you can call this 2 to the x minus 3 and 2 to the x plus 3. Right? If you were to check it, you'd say, hey, this does equal this, yes. This does equal this, yes. And those middle 2 parts are equal and opposite, so they'll cancel out. Right? Now, there's no way your brain should do this immediately on your own. Right? I mean, I don't know how to do that because I'm a genius. I know how to do that because I've done a million of them, and I did them with people who knew the tricks. Yeah? So I'm just showing you the tricks. Cool? But don't think that, like, you need to, it's the same number of type of tricks that just run over and over again.
How do you know it would be a plus and a minus?
I know that there's no middle term. There's no like blend of things with exponents.
It would look like.
Yeah, and so they have to be the same and put opposite signs.
So you would just have to think of them.
Yeah, because if they're the same signs, you'll get a 3 times. Yeah.
These term.
Yeah, exactly. You get a middle term. Cool. All right, take that. Try the same game with this. See if you can get that 6. If you can beat that 6 into being a 3, and see if you can cancel things out, make it a little prettier. So I think this kind of math has a lot of wishful thinking in it. Like, this would be so much nicer if that was a 3 to the n. And so you can like play that game where you try to weasel your way into that wishful thinking space by taking that 6 and just making it something with a 3 in it. I'm looking for 3s. So how can I get that 6 to be a 3? And you also have to do it like while you're like playing the right game and not making stuff up. I know 6 is 2 times 3, and that makes me think like, how can I break up that n? Well, if you have a 2 times x and you have 3 of them, you have 2 times x and 2 times x and 2 times x. So you have 3 sets of 2 and 3 sets of x. So it sort of distributes in. Just make sure that's legit before you start doing stuff. That's legit. So I have n sets of 2 and I have n sets of 3. I broke this up into this fraction, and I broke it up into that fraction. You can do that, like 1/4 and 2/4 is 3/4, which is 1 plus 2, 1 plus 2 fourths. So instead of having an addition, I just kind of broke it into those pieces. Again, fraction work. This is 1, that's not a big deal, Shazam. And then those cancel and you're left with the 2n. Yeah?
I have a question.
Yeah.
Because like the maths makes sense in this, but actually knowing what to do and how to get there.
Totally, exactly. And that's why like I don't want you to think that you need to have guessed this. I'm just trying to show you like the 3 tricks that I see over and over again. One is make the thing that you don't like, force its base to be what you want it to be. Now, all of these have been engineered by some just mean-spirited person, but it means that all of them will kind of work out nicely. So kind of follow the tricks that I'm showing you, a couple of them here and there. Try some on your own, but there's not too many tricks that kind of follow the same things, same patterns, right? And that's why we practice. Cool. And speaking of that, Shazam! I think we should be up through like factoring expressions with exponents. We can stop once you're to the end of that. We'll just spend the rest of the time getting some practice in. Again, there's a lot of problems in there, so once you see the tricks and you're like, I'm confident with this, move on. But don't feel like I was the kind of student that needed to see all of them.
Do we do the factoring phase or not?
Go up, like stop when you see this guy. Yeah, so finish that one.